Okay, so let's finish this off with the last page of that review. We start off with honestly what I think should be a fairly simple question, because if we look at this problem, there's some pretty substantial hints that are going on, that we have some equation. I actually called it F, and I realized right there it says G, so I should use G, so I'm matching my own letters. But I notice that there might be a coefficient out in front. I could call it K or A, or it doesn't really matter. But I can see right away that it has a linear factor right here. So I should have some kind of an X plus 1. I notice that there's a bump right here. So it looks like some kind of like maybe an X minus 1. I would imagine squared. It could be to the fourth power, but it doesn't look as flat. And then I notice a cubic root over here at 3. So I think that seems like a pretty solid graph right there. Now, the other thing that says, let's go ahead and modify that equation so that when I plug in 4, in fact, I get the number 9. So way over here at 4, somewhere way up here, it goes through 9. And so as we look through that, there's literally only one way to do that. So if I plug in 9 for g of x, and I plugged in 4 for x, that's going to be a 5. If I plug in 4, 4 minus 1 is 3. And if I plug in 4 right there, I'd get 1 cubed. So putting that all together, 5 times 9 is 45. So it looks to me like if I divide both sides, I would get 1/5. So my literal equation, not the general one, but the very specific equation, is 1/5 of x plus 1, x minus 1 quantity squared, and x minus 3 cubed. And if you actually graph this in Desmos or on your graphing calculator, this is the exact graph that you would get under that window, because that's kind of how I did it. Now, in terms of the review stuff, we're going to kind of go through this in a little bit of a quicker way. I've got some things I need to do, so I'm going to go ahead and just hold up this answer right here. Now, notice it says 11 because I did modify this a little bit. But what I noticed when I looked at this problem, I noticed that since the powers here match, the ratio of 3 to 6 should be a horizontal asymptote at y equals 1/2. Now, when we talk about the domain, we have to be a little bit careful here because we don't want to divide by 0. So when I factor this denominator that I do not want to divide by 0, I got 6x minus 1 and x plus 4, which would mean the domain says do not pick 1/6 and do not pick -4, because that would force us to divide by 0. Now, unfortunately, what that does for us, which is a little bit of a bummer, is this is the domain, but the asymptotes look almost the same. Notice this says don't do it. This says is what happens if you do it. So notice this says do not pick 1/6, because if you do, there's an asymptote. Now in 10b, yours says 10b, when I factor the stuff underneath that root, what I'm worried about is that I'm taking the square root. Now there's no division here, so that's not a problem. But what there is the potential of taking a root of 0. So after I factored my problem, and I noticed that these all had a 2 and an x in common, so that was my GCF. This was a very easy quadratic that was left to factor, which is a 4 and a 1 to make the 4 and the 5 work. I made a little sign chart. Sometimes we call that a decision chart. And then I just tested numbers. Like if I go above 0, like 8 or something like that, I'd get a positive, and a positive. And I tried something in here like -0.5, and I'd get a negative, a positive, and a positive. Anyway, as you go through that process of testing numbers, they do tend to alternate signs because no terms bounced or anything like that we've seen in these other problems. And so I just noticed that the places I do not want to be is where the answer is negative. So it's okay to take a root between -4 and 1. And it's okay to take a root of anything 0 to positive. And there are no asymptotes because this problem doesn't ever divide by 0. So we don't have that, and we don't have a rational equation. Now, the last one that is a little bit trickier, I had mixed emotions about doing this, but we do have two things to worry about. I don't want to divide by 0, so I don't want the number 5 or -5, because that would take the bottom down to 0. But then I also don't want to take the square root of a negative. So when I put the numerator to 0, I got 3/5. And it's okay to have 0 on top. It's okay to have positives on top. But what you can't do is have 0 in the bottom, and you can't have the square roots of negatives, because all of these out here would be the square root of negative, and we can't be out that way. So putting it all together, it looks like my domain was okay from 3/5 to 5, not included, and then from 5 to infinity. And the only other thing that was kind of strange about this problem is when you look at it, since the numerator is actually technically x to the 1/2 and the denominator is an x squared, this is one of those special problems where the degree of the numerator is smaller than the denominator, and anytime the top is smaller than the bottom, that drives us down to 0. Notice below it says a 1/2 degree over a 2nd degree. Bottom's clearly larger. That's going to drive us down to an asymptote at 0. That's going to end the review. That's number 10. I know it says 11, but you know what I mean. So I will see you back in class.